Is it okay? So thank you for the warm introduction. So it is an honor and a privilege to speak with you today. My presentation will focus on fecal pH testing as a method to diagnose metabolic acidosis, which may be very useful for many veterinarians working in the field to treat diarrhea. I will begin with an introduction to the topic with brief review of diarrhea. So the diarrhea in cows can lead to severe economic losses because it delays body weight gain in cows, incurs costs for treatment, and in severe cases, cause death. So I emphasize that appropriate treatment for diarrhea is very important to prevent such losses. Diarrhea causes 4 main symptoms, including dehydration, hypoglycemia, electrolyte abnormalities, and metabolic acidosis. Although all 4 are very important and may result in death, my primary focus of my presentation is on metabolic acidosis. So the treatment for metabolic acidosis involves the use of an alkalizer, such as sodium bicarbonate. However, if sodium bicarbonate is not administered in proper quantities, it may lead to iatrogenic alkalosis or the persistence of metabolic acidosis. So it is important to determine whether the cow is actually experiencing metabolic acidosis and whether the appropriate volume of alkalizer was administered. And so Casares clinical score and blood chemical test among the methods to detect metabolic acidosis. The Casares clinical score are commonly used by many veterinarians because they are performed easily and cow-side immediately and locally. However, dehydration makes it difficult to detect metabolic acidosis because it causes similar symptoms as metabolic acidosis and affects the scoring regardless of the disorder of acid-base balance in cows. And blood chemical test is among the best methods to detect metabolic acidosis, but their high cost should be carefully considered. And they require any special equipment, for example, isostat analyzer. So it is not a method that veterinarians working in the field can always perform. So low-cost method that can be performed easily anywhere and anytime is needed. We hypothesize that measurement of fecal pH is such a valuable method. Fecal pH has several advantages, including low cost, performed cow-side immediately and easily. However, little about the method has been reported, and the relationship between fecal pH and metabolic acidosis remains unclear. So, the purpose of this study comprises 3 parts. First, to examine the relationship between fecal pH and blood gas. Second, to examine the reliability as diagnostic method of fecal pH for metabolic acidosis. And finally, to examine whether the pathogens of diarrhea affects its reliability or not. So let me move on to the material and method. 138 samples from Japanese black cattle, Japanese black calves in Fukushima Prefecture between November 2016 and June and November 17 were collected. There are 120 normal diuretic samples and 18 healthy samples. Test items were measuring blood gas and fecal pH and clinical score, which were performed cow-side immediately, and pathogens were detected using real-time polymerase chain reaction analysis. Modified Casares clinical score was performed, and based on this table, there are 3 clinical factors: activity, milk sucking ability, and fecal color. Healthy calves were assigned from score of 0 for all parameters, and the blood gas and fecal pH were measured following the protocol. Blood samples were drawn from a jugular vein, and blood pH were measured using an isostat analyzer and EC8 cartridges, and calcite immediately. Fecal pH were measured using a pH meter, and it takes only 3 minutes to complete a measurement. And one sample for fecal pH measurement is about 40 times less expensive than fecal blood pH measurement, and moreover, in terms of cost for instruments, fecal pH meter is significantly less expensive than isostat analyzer. And real-time PCR performed to detect pathogens in diarrhea. Target pathogens listed this table. We collected samples and sent to other university and doing real-time PCR. So our data of this study follow. I will explain the outline. First, I will explain the correlation of these groups. Delta explains the difference immediately before treatment and the next day. Subsequently, I will explain the sensitivity of specificity, utility of clinical score, and fecal pH to predict metabolic acidosis. And finally, I will explain the identified pathogens of their effects. So, in this slide, these plots explain blood gas and clinical score correlations. The vertical axis shows the clinical score, and horizontal axis represents the bicarbonate ion concentration at the lower left, and the blood pH at the upper right, and base excess on the lower right. The mild correlations were confirmed using Pearson's correlations. In this slide, this explains the blood gas and fecal pH correlations. The vertical axis represents the fecal pH. In this slide, the significant positive correlations were confirmed. And the correlation between the differences before and after treatment were evaluated as delta. But vertical axis shows delta blood pH, and horizontal axis shows delta fecal pH. These are also confirmed the significant positive correlations. Cutoff values for fecal pH and clinical score for metabolic acidosis were evaluated using receiver operator characteristic curve analysis. Cutoff values for fecal pH to be 5.75 and clinical score were 2. The sensitivity reached its highest value with the combination of fecal pH and clinical score, the values. And specificity, however, reached the highest value with in fecal pH alone. This real-time PCR detected several types of pathogens in fecal samples. This plot detected identified pathogens. Rotavirus group A and Cryptosporidium parvum accounted for the majority of detected pathogens. However, the one half of the pathogens could not be detected. And we examined whether the combination of fecal pH and clinical score differed in detection sensitivity and specificity between the pathogen identified and non-identified groups. no significant difference were confirmed. So, in conclusion, we provide supportive evidence the fecal pH correlated with blood pH, bicarbonate ion, and BSXS. And the differences before and after treatment were also correlated. From this result, we conclude that fecal pH detects the disorder of acid-base balance relating to diarrhea in calves, and it is also useful to monitor their recovery from the disorder. Here's more. It was found that metabolic acidosis could be detected with a considerable accuracy using the clinical score and fecal pH, regardless of pathogens. As I mentioned, measurement of fecal pH is inexpensive and performed easily anywhere and anytime. So we hope that measurement of fecal pH contributes to more effective diagnosis and treatment of metabolic acidosis in field. Thank you very much.